Every single time we solve a integral using the method of partial fraction decomposition, our goal is to break apart a rational function into simpler rational functions. And the way that we do so changes based on how we factor the denominator. So in the previous example, the denominator factored as three distinct linear factors. Here we will see again, linear factor decomposition, but one of those linear factors will have multiplicity too. So let's go ahead and do the same thing that we did before and just play with the integrand. And we will bring back the integral later when we rewrite the integrand. We have 6x plus 7 over x squared plus 4x plus 4. Again, our goal is to factor the denominator as much as we can. You can notice the x squared plus 4x plus 4 quadratic function factors as x plus 2 squared. So the linear factor x plus 2 has multiplicity 2, right? It occurs more than once in the factorization. And that's what's going to make this problem a little bit different than the previous one. Here, we're going to give ourselves an unknown fraction for the x plus 2 factor. But because it occurs twice, we're going to give it two fractions, one for the first multiplicity, one for the second multiplicity. And now our job is the same. Let's figure out what a and b have to be in order to decompose this fraction in this way. So my denominator over here is x plus 2 squared. So I need all my denominators over here to be x plus 2 squared, which means I need to take the a and multiply it by an extra x plus 2. Now it has the right denominator. My b already has the right denominator, so I don't need to do anything there. It already has x plus 2 squared. So we have a common denominator, which means that ax plus 2a plus b over x plus 2 squared is equal to 6x plus 7 over x plus 2 squared. And we will again match up coefficients. So I've got 6x's over here, and I've got a of them over there. And that's pretty much it. So it's one of the easiest equations that you can write down. A has to be 6. I have 7 constants on my left-hand side, and I have 2a plus b of them on my right-hand side. So solving this very easy system of linear equations tells you that a is 6. You already knew that because that was your first equation. And your b has to be minus 5. So this integral up here can be rewritten as the integral of a over x plus 2 plus b, which would be a minus 5, over x plus 2 squared. Now, our first fraction is going to antidifferentiate as a natural log. We have 6 times the natural log of x plus 2 in absolute value. The second fraction is going to antidifferentiate via a u substitution as minus 5, so it ends up being plus 5 over x plus 2 with our arbitrary constant plus c. So the main difference here is anytime you have a linear term, or really any term, that occurs with extra multiplicity, right? If it's x plus 1 squared or x plus 3 cubed, you create a new fraction for every multiplicity.